important topic from mathematical method of physics. So before going to start, if you are new to my channel, please subscribe my channel, press the bell icon for notification so that you will get the information regarding upcoming videos. So let us start. Laplace transformation, as we know, it is a piecewise continuous function. If it has a finite number of breaks, it doesn't blow up to infinity anywhere. And this Laplace transformation we used to denote it by f of t. As the definition indicates, it is a piecewise continuous function and it has a finite number of breaks. It doesn't blow up to infinity anywhere. Okay. Laplace transformation, as we know, it is denoted by small f of t. We can also write it in terms of symbol L as a flower bracket of f of t, or capital F of s. So Laplace transformation helps to solve a differential equation and it reduces differential equations into algebraic problem. Okay. Laplace transformation usually we denote in terms of integral. Okay, this is the Laplace transformation equation. So we usually denote it in terms of integral transform of the given derivative function, that is f of t, with real variable t and t to convert into complex function with variable e to the power minus s. Okay, where t is greater than or equal to 0, and f of t be given and assume the function satisfies certain conditions to be stated. Okay, if we solve some problem, we can understand f of t is going to be given in the problem. You have to solve the Laplace transformation. So and Laplace transformation, as we have denoted, is called one-sided Laplace transformation. There is also two-sided version of integral form from minus infinity to plus infinity. So some of the properties of Laplace transformation we must know: linearity, scaling, time shift, frequency shift, time differentiation, time integration, frequency differentiation, frequency integration, time periodicity, initial value, final value, and convolution theorem. Very important properties. So linearity is very simple and easy to understand. This is the function given and you have to write the Laplace transformation of it, that is f of s. So linearity problem, as we can understand easily. Scaling, this is the these are the formulas or the theorems we have to derive, and we will get the Laplace transformation of them. So I have written all the properties. Okay, Laplace transformations. Just you have to practice these properties. So you can just solve the given problem, or you can understand the given problem if you understand these properties. Okay. Then some of the important formulas for to solve a problem. So Laplace transformation of some of the parameters has been given. Laplace transformation of 1 is 1 divided by s. You have to practice all these formulas. E to the power at, t to the power n. Directly you can solve the problem if you know these formulas. So practice all these given formulas here for Laplace transformation. Then you can easily solve the problem. So inverse Laplace transformation. As we know, Laplace transformation, inverse Laplace transformation is also there, like trigonometry, inverse trigonometry, as we have. So inverse Laplace transformation, as in the name indicates, we can write the formula like this: f of t is equal to L inverse f of s. So as usually L f of t is what? Laplace transformation. If we want to write inverse, then we will get again the function f of t if we take the L inverse. So For two Laplace transformations also you can write the Laplace inverse transformation if there are constants a and b are involved. Then inverse Laplace transformation formulas also you have to practice. Just if you understand Laplace transformation, you can easily write the formulas for inverse Laplace transformation. Reverse of that. Okay, try to practice these formulas also. And as we know what is the use of Laplace equation, we have already studied Laplace equation in physics and maths. It is a second order differential equation or a two-dimensional equation. So if we consider um, two-dimensional, then we can just consider x and y coordinate. If we consider three dimension, then we can write the second order derivative of Laplace transformation, that is del square f is equal to 0. Some of the problems we will try to solve related to Laplace transformation. So first if we have the formula like f of t, Laplace transform of f of t is what? 1. We have different formulas, so how this will be 1? You can just try to understand. You just use the standard equation for Laplace transformation, L of 1, that is nothing but f of t. That is what? Capital F of s is equal to what is the formula? 0 to infinity e to the power minus st into dt, because f of t is 1 here. So just 1 you can consider. If we put limit 0 to a, then e to the power minus st dt, just you have to integrate with respect to time, then e to the power minus st divided by s you will get. Put the limit 0 to a, just you have to replace a infinity with a, capital A. Then finally you will get here if you put the limits, this is going to be 0 second term, the first term is left with 1 divided by s, so where s is greater than 0. So this is how Laplace transformation of 1 is what? 1 divided by s. Like that you can try to solve a Laplace transformation of t, how it would be 1 divided by s square. Okay, just follow the same procedure and put the limits, you will get the answer 1 divided by s square. So like that you will get the formulas related to Laplace transformation. These are some examples. Then let us solve some important problems. What is the Laplace transformation of 1 minus cos t by small t?